interesting difference in particular in computer science is that now for convolutional neural networks class at Stanford, lots of people from different departments are joining. So as I remember, when I was here at the University of Warsaw, the computer science department was kind of siloed.
Hi Łukasz.
Hi Michał.
So you are currently doing your postdoc at Stanford, and whenever I hear Stanford, I also hear startup. And I wonder what's so innovative about Stanford that students are able to open their own companies apart from being in Silicon Valley.
Right, I think the Silicon Valley part is the key part, in the sense that it's not only about the place, but also about the resources and the people and mentorship that we find there. And so I think that the unique part of Stanford is that people just help each other, and that there is some big trust that in the community. So whenever you are asked to help someone, you help them without thinking about the consequences of this help, but then at some point in the future, this help comes back to you. And that's seen at many levels, on the student level, on the faculty level, and so on. So there's this self-fulfilling prophecy because people just trust in startups from Stanford, and therefore there are more startups which are successful, and then people invest more in those startups, and it's kind of a rich get richer principle, but that's how it is.
All right, and a lot of students in Poland, usually when finishing computer science, they usually become software engineers. Some of them open their own software houses, but it's really rarely when you see a person actually creating his or her own product. So what would you recommend Polish universities to do in order to foster such a disruptive culture of creating own products?
I think that the main difference between Stanford and Polish universities is that their classes are all around some projects and teamwork on the projects. And this stimulates thinking about not only how to solve the problem, but also how to communicate the problem with others, how to find the actual problem to solve. I think here at the University of Warsaw, we have engineers which are world-class and top engineers that can solve any problem that they're given. The problem is with finding the problem worth solving. And we could be trained to get these skills and to find issues in current industries, and just talk with people who could give us something interesting to solve, but that's, at least at the moment, it's not taught at the university.
All right, so you've actually co-founded 3 startups, if I'm counting correctly. First one was DeepArt, which the main idea behind it was to move stylistic elements from one picture to another. And I wonder, how did it start? Right,
so DeepArt started when I was at EPFL in Switzerland, and with one of my colleagues from my PhD years in Brussels, we found on the internet a paper from Tübingen where they used neural networks to generate artistic images. We found some code online, we found the paper, and we were playing with the code, with implementations, with our own parts of the implementation. We figured out that it's fun and cool, and that there might be an interesting product for people out there. So we simply set up a website. Within a week or so, we put together AWS resources, and we just released the product where people were able to submit images, run the neural networks in the cloud, and get their artworks created. It was around 2015, so that was the time that neural networks were just taking off. So on this wave of neural networks, we managed to get some traction, and we managed to get quite a lot of interest. And then we realized that we need to increase the human resources in the team. So we actually brought the original authors of the paper to the team of DeepArt. So there was 5 of us, and we were trying to make this as successful as possible. We realized many problems on the way, that the product is clearly an entertainment product, and after a while, people just are not interested in using that for entertainment. So we would either need to target specific audience of artists who may use it for their art projects, or include some social network features and so on. And at that time, no one in the team was actually interested in moving that forward. So at this point, DeepArt is a website where you can still do this image processing, but it's not a startup in the sense that we're growing exponentially and so on. So it was more about testing an idea, and the test went well, but like it didn't bring us further, unfortunately.
All right, so how did you bring the original authors of the paper to the project? Did you know them before, or did you just contacted them?
Yeah, so we wanted to move the technology forward, so the natural thing was to find people who are able to do that. We could do that, but we had already a lot of other tasks on our on our plates, so we decided to just contact them and a few other people in the field who are influential in this domain, and so we just cold emailed them. They answered that, yeah, let's meet, and we flew to Tübingen, met them, we liked each other, we went for a party, for beers, and that's how it started.
All right, and I saw that on the website you can actually buy an artwork created by a neural network, and I wonder how many people actually did buy it.
So I think so. We have around 5 million images processed on the website. The exact number for daily sales is roughly enough to keep our servers going. So I don't know the exact numbers, but it's in like up to 1% of all the images that we produce.
Okay, and so the next initiative you co-founded was Hellfire. The idea is to bring together people from different disciplines to tackle the problems related to medicine. And can you tell us how such an interdisciplinary team work?
Right, so coming back to Stanford again, it's actually something quite unique at Stanford, that people try to bring experts from multiple fields to build something that none of the individual parts could build on their own. And that also happened with Health AI. So just motivated by this Stanford spirit, I wanted to create a group for healthcare and AI. As a researcher in bioengineering and with some background in machine learning and statistics, I realized that, again, like we, on the computer science side, we know perfectly how to solve problems, but we don't know which problems are worth solving. So let's just ask people in the School of Medicine there or in the Stanford's hospital on what kind of data they possess, what kind of problems we can figure out. So that's how it all started, and that's what it is.
Yeah, and I also saw that there are people from business school also joining the project. So how do they actually help you realize the vision?
Right. The thought that we had initially was that we have people who can solve problems, the engineers, and now we have also medical part that can give us problems. But now, to really solve a problem, it's not only about writing a piece of software, but also to deploy it at scale. And for that, you need to understand specifics of the actual field, and like you need to do some business modeling to understand if that can really take off as a solution. So otherwise, we would rather be in the space of writing scientific papers, which is great. But if we bring on this business component, we can multiply the impact.
All right, then so do you actually sell these solutions, or you just release them as free? So
the group has actually structure similar as PL in ML. We just want to bring the people together, they can interact, and then they can venture on their own. And that's how it's actually happening. So my personal motivation was exactly that. Just I wanted to meet people who have similar interests and then start with them something. So in the group, we are running hackathons, we are running seminars for people to meet and to iterate quickly on the ideas, but then it's up to them how to actually deploy them.
Okay, I see. So there is no real person responsible for all of the projects, but rather small teams of people working on different projects.
Right. So these are seminars, hackathons, and like more events and meetings, and then just people team up. That's it.
And do you learn from each other? Like, how do you exchange the expertise in a given field between each other?
So I think the best example for that is the hackathon, where we had around equal distribution of people from business side, from medicine, and from engineering, and then they created around 10 teams of around six people, again bringing all this expertise together. So just by the fact of putting people with so different expertise at one table, we can get great results. Especially that computer science people tend to look down at people in business and vice versa. So if you just break this and like they start to respect each other, they can actually achieve great things.
Okay, so let's move to the next actually startup you co-founded, Sky Blue AI, right? I couldn't find much information on the website. I saw that you started like 1 year ago.
Right.
Could you tell us a little more about it?
Right. So this one started from a project that I was working on with my colleague from high school. Actually, now she's at the University of Warsaw doing her PhD. We were trying to solve the problem of car insurance. So what she's trying to do is to better predict risk of car accident using some data. And then she has data from insurance companies on the addresses of people living at certain places, and then their number of accidents they had in a given time. And what insurance companies are doing right now, they basically aggregate on the zip code level the risk, and then based on that, they give you your insurance premium. What we were trying to do is to just go deeper and to look on the satellite views of the houses where the people live, and based on that, we wanted to include more features in the model and predict the car accident risk. And it turned out that it works well. So we wrote quite a cool paper on that, showing that just from the satellite image, you can actually predict risk of a car accident just by looking on the roof of your house and so on. So there is some signal. We were not able to actually discriminate where the signal comes from, but like there is a correlation that could be used for a business case. So then there's an interesting business case, and my friend decided to move forward with that. I'm right now less involved in the startup, but I helped with building the technology.
Okay, so the idea is that you input the image to the neural network and it spits out the probability that the car will have crash?
Almost. So it's more about you input, like the actual input is the address. The address is of course associated with some geographic location, so we just crop out a satellite image from this location, and this comes into a neural network, but then the output of the neural network is, for example, how much of green area is around the building, or is it just are there many buildings around the address, and so on. So it turns out that those features are correlated with the risk. So if you just live somewhere outside of the big city and there are no roads and so on, it's maybe more likely a little bit that you will get a car accident. And those super tiny probabilities can sum up to something meaningful for a company.
Okay, so you are actually predicting the features
right.
For the next model, which will
right, exactly. That's correct. Okay. That's correct. And you just add that to an existing model.
Okay, so let's move to the next startup, Salience AI. You co-founded it this year, actually.
Right.
The website looks like it's ready to go. So I'm curious, in what way you allow companies, medical companies, to use your product and actually AI.
Right. So this is something that I'm really focused on right now, and that's one of the main things that I'm working on. The idea is that we've been working in the lab on neural networks for extracting biomarkers from X-ray images, and particularly for knee osteoarthritis, which is like just a disease affecting elderly people. So we designed those biomarkers using neural networks and X-ray images, and now we were trying to sell those biomarkers. So those, where by biomarkers I mean like predictors of the disease, or like the prediction of the severity of disease. So we were trying to sell that. We went to several companies, And we realized that the companies are more interested in actually how we got to those biomarkers, like the process that we set up, rather than the biomarkers themselves. So we pivoted a little bit, or quite significantly actually, and we created a platform where you can aggregate images from multiple sources. You can annotate those images, or you can just crop them and like bring them to a similar format. Then you can run AutoML kind of solutions on that to get your first models, and then that's how you get actually the biomarkers. So we simplified the entire process just by removing this 80% of data cleaning part of that the data scientists need to just leave with. So that the most painful part of life of a data scientist. And it's turned out that this very basic product is actually more valuable than those sophisticated neural networks that we built at the end.
Okay, but from what I understand, these companies still require engineers to actually use your product, or they can use it even without engineers.
So in theory, they could use it without engineers. We output some AutoML product, but then you actually would rather want someone to validate that and to rework that. But still, the person working on that can really focus on this innovative work of a deep learning engineer rather than on cleaning the data, basically.
All right. And have you found funding for the company already?
So we are now accepted to one accelerator, and by the end of the year we'll be looking for a small pre-seed round, and then next year we're looking for a seed round.
All right. And most of the projects we were talking about required a team of specialists, right? And you were talking that the Stanford allows you to find people who are interested in these ideas. And do you feel that this is the most important part in finding the best team, that you are on Stanford, or maybe there is another way you actually find these people?
Right. So, first of all, definitely finding the right people is the main part of running a company, as far as I understand that. And so for me, it was my personal focus on finding a co-founder that I'm really comfortable working with, but like that I trust a lot, and like I'm confident that the person just believes in the same values as I do. So that's something that definitely we need to look for. And now finding these people is actually surprisingly, I wouldn't say it's easy, but there are, in our generation, what I've realized is that there are lots of people in Google, Facebook, and big companies earning a lot of money, but kind of not necessarily satisfied with what they're doing in these big corporations. And we have this great freedom that we can actually just sacrifice half of our salary there in Silicon Valley, still earn decent living, but then focus on things that we are really excited about. So as long as you're able to excite other people, and like as long as you can share the passion and you can share values and trust and so on, then people just want to work with you actually. And that's great, and that's beautiful, especially if your product is actually has some value other than just producing money, but you're in healthcare, for example. So yes, I think it's even though the AI talent is scarce, it's still possible. And then there's another side of finding collaborators. There are just a lot of freelancers in distinct parts of the world that also are in a similar situation, that they just want to work on something exciting, and then maybe on the economics work well, because in Silicon Valley we can get a lot of money, and then depending on where they are in the world, they can get a decent salary for the place where they are, and so on. So like there are many ways you can actually collect and create a great team now.
Okay. And even though you are really into startups, you actually are currently pursuing your postdoc at Stanford. Could you tell us how do you join the startup world and the postdoc world, or maybe they are even somehow linked?
Right. So it would be quite hard to have it completely distinct. In our case, both me and my co-founder are in a lab at Stanford right now. But the projects that we're working on at Stanford are actually using the platform that we built in the company. So we can quickly iterate on neural networks for certain diseases and so on, so that we can produce valuable and meaningful work academically and show it as a use case of actually our pipelines. So that's in this case, it's quite straightforward actually, yeah.
Okay, so yeah, applications. When I was looking at your CV, you seem to do a lot of theoretical stuff before, and then you have switched to the applications. Could you tell us why did you decided to do that?
So that's correct. So I did my PhD in mathematical statistics, like in time series in Hilbert spaces, which was fairly theoretical. But then I was also involved in startup world before, so it was kind of intervening with each other. But I also think that there are at least two big ways on how you can join the startup world. You can either think about startups in this idealistic way that you just drop out right away from your undergrad and you just start a Facebook and then you're super rich and so on. That's one path that works sometimes, but like the risk is very huge. Another one is that you gain a lot of expertise in certain areas. You talk with people on their research, on their problems, especially if you're joining some applied laboratories, you're able to actually interact with people who solve problems on a daily basis or have problems that are worth solving. So this being in the academia and like just gaining expertise actually gives you a possibility to just to run startups from a different position where you're not competing with everyone in the world who can build your Facebook for cats app, but you're competing only with people with like very specific expertise of applying neural networks for certain bioengineering problems.
All right, I see. So my last question will be related to research, actually, side of your life. And how do you do you see a difference in doing, in a way, research is done in Europe and in the USA? And could you tell us more about it?
So I think the main differences are related to what I was mentioning at the beginning, that at Stanford especially, so I cannot talk about the US, I have my sample only from like the universities that I visited, so mainly Stanford and like short internships in other universities. So I think the main difference is that it's very projects focused. So whenever you're joining a computer science class, you will definitely spend half of your time on a project on how to apply a new method in machine learning for some problem. Also, an interesting difference in particular in computer science is that now for convolutional neural networks class at Stanford, lots of people from different departments are joining. So as I remember, when I was here at the University of Warsaw, the computer science department was kind of siloed, like the geniuses there are siloed, which is great for building, for teaching sophisticated algorithms and so on, but it actually doesn't stimulate collaboration and interdisciplinary work. So at Stanford, for the convolutional neural networks class, you can find people from geography or from history, where they analyze old texts with convolutional neural networks and so on. So that, I believe, is a big thing that we could learn here from Stanford. On the other side, as I was saying, like we have top engineers in the world, we have top algorithmics people, and that's the product of our approach to science. So it's hard to say which one is better. From the economical standpoint, Stanford is doing well, but that's not necessarily the only value that we have in the world. So there are values that we have at the University of Warsaw, and that's great too.
All right, Łukasz, thank you for the interview. I wish you luck with startups and with research.
Great, thank you very much. It was a lot of fun.